process. Andy Alden serves as the Executive Director of the Interstate 81 Corridor Coalition and leads the Eco Transportation and Alternative Systems Research Group at the Virginia Tech Transportation Institute. He is a registered professional engineer who has worked in the environmental and information technology fields and in the development and deployment of vehicle data acquisition systems and related naturalistic research methods. His current focus is in advancing safe and sustainable transportation through the application of emerging and alternative technologies. Recent research has focused on automated last-mile shuttles, road weather safety, bus transit efficiency, animal vehicle conflict, applied road salt impacts, and the use of unmanned aerial systems in support of surface transportation. Andy?
We have a laser?
Yes,
oh,
this
great.
laser there. Thanks.
Can everybody hear me okay? Sounds like it. Well, good morning, everyone. I guess I'll just get started. Let's see, is this working? Yeah, this is great. I like to start out talking about why something we're talking about is an issue. Winter affected roads impact us in a variety of ways. Foremost is safety. According to Federal Highway, through the years 2005 to 2014, we had on average about 1,800 fatalities per year. That's a pretty big number, and that's basically related to winter weather. That doesn't include rain. It also affects mobility in the system, which is a big issue, especially on interstates. When you have crashes and when you have vehicles slowing down, of course that affects your speed, the volume you can handle, and capacity of the system. And you can see how much that decreases there. It also hits DOT budgets pretty hard, although it sounds like it's hitting them less than it used to. And then there's a lot of issues with public expectations, which you've already heard about today. But if you look at all the different weather crashes altogether, you can see that wet pavement causes the most of them. But when you start getting into winter weather crashes, there's quite a bit of those that are caused by that also. And there's some other interesting things that come up too. Not only do the roads get iced up, but we're starting to see these sorts of things occur, impacts on vehicles. Since we've converted over to LED signal lights in a lot of places, they no longer warm up to the temperature where the ice will melt off. And so we start to see this. And this is kind of an interesting phenomenon too, because as you hear more and more things about autonomous vehicles, well, most of the autonomous vehicles still rely upon camera view of that signal to determine whether or not they can go at an intersection. And so there's a lot of ways that winter weather impacts transportation. Some of the ways that we're dealing with it, and some of the reasons that things are actually better out there than they used to be, is the vehicles have gotten better. We don't talk about that often. We've got a lot better tires than we used to. We have some really advanced systems on cars that work well. I know the car that I drive actually has 10 different modes that the system can ride in. In the wintertime, it's an all-wheel drive, and you can put it in different modes. And so analog brakes, stability control, and traction control, all these things have made driving in winter conditions better. And so maybe the level of service doesn't need to be quite as high as it would be for cars that are advanced like that to handle them. We'll talk about that. I know that Wilf's going to talk about some of this stuff later on. Plowing is one way to clean the roads off. Primarily what I want to talk about today is salt. And as Marion was talking about earlier, they brine the roads. You'll see the stripes on the road a lot of times. And the primary reason you put that out there is just to prevent that the snow that falls on top of that from bonding to the pavement, so that when they do come along later with the plows, it pulls it off much more easily. Primarily what I want to talk today is about granular material, and specifically salts. We have these sodium chloride, calcium chloride, magnesium chloride. There's also something called calcium magnesium acetate and blends, and I think that Diana's going to talk about some of those alternatives in another presentation. We also put down aggregates on the road for mechanical traction improvement. Typically that's sand. In some places they put down bigger pieces of gravel. But that's its own separate issue. I have a friend that lives in Colorado and works out there with the DOT, and they put down primarily sand. Well, when that sand washes into the rivers and streams, it causes a lot of problems there too, because it'll completely cover the bottom of the stream and kill the life that's living down there, all the benthic life. So it's not free of its own problems. And then there's something that's called pre-wetting. We'll talk a little bit about it, and that's just the idea of once you put this granular material, whether it's an aggregate or a salt in the back of a truck like that, a lot of times they'll put a wetting agent on top of that, and it wets it literally. And typically that's brine that's put on there, and it has a couple different purposes. And I'll talk a little bit about that. So this is really the mechanics behind how salt actually removes ice, and it's pretty interesting. Ice, let's see where I want to start with this. Ice is interesting. Frozen water is a really interesting thing to start with. It's one of the few liquids out there, if not the only liquid, that actually expands when it freezes, when it solidifies. And ice, believe it or not, once it gets below a certain temperature, actually is not slippery. In fact, you can walk on it very easily when it's below a certain. It's only when it's above a certain temperature that this ice layer, actually a water layer, forms on the top of the ice, and that's what actually allows you to ice skate, and that's why the roads are slippery. A lot of people think it's because it's the pressure of the ice skate on the ice melts the ice. That's not the truth. There's been apparently, and I was researching this, there's been a lot of debate over that over the years. There's still people on both sides of the issue, but what it really comes down to is there's a little bit of a layer of water. And the reason that's important is because when you put down a granular solid material like salt on the roadways, it needs to dissolve. And if you were putting down salt on top of another solid like ice, and if it's below a certain temperature, it wouldn't dissolve. So what's important about the dissolving part of that is that as you add, water by itself is, of course, freezes at 32 degrees Fahrenheit, but as you add impurities to water, it depresses the temperature at which it freezes. It also changes, it increases the temperature at which it boils. So it works in both directions. But that graph right there kind of shows if you have the freezing point of water and how it decreases as you add sodium chloride to it. And once you add the salt to the water, what's really interesting, the reason that it depresses that freezing point is because the water molecules actually create this lattice when they start to solidify. And once you add the salt to the water, the sodium chloride molecules actually are pulled apart by the water molecules. Water is what they call a polar molecule because it has two negative hydrogens on one side. We all know the formula H2O. Well, there's two H's here and there's an O here. The O is positively charged and this side is negatively charged, so it's called a polar molecule. And it pulls apart the sodium and chloride and it dissociates it into the water. Then once the sodium chloride get in there, they kind of mix themselves into this matrix and they prevent it from forming. And so that's what depresses that water, the freezing point of that. And what you get when you see it on the surface is this is actually a piece of salt that's on a piece of ice. And you start seeing, as it starts dissolving, you'll start seeing that meltwater push out there, and the process will actually kind of increase from there. And I've seen this all too painfully at firsthand and watched it from beginning to end. On the way to work one day, I rolled my truck off the road and ended up upside down. First thing I thought of was flames and fire, so I reached up and turned off the ignition. And then I realized that my windows were electric and there was no way to get out of the vehicle. So I turned the key back on again, rolled the window up, and then turned the key back off again. And then when I undid my seatbelt and hit my head on the top of the roof of my car as I fell down onto it, I crawled out the window and I walked up to the road to call a wrecker. I'm standing up the road with a wrecker and I'm flagging down people and telling them to slow down because it's really slippery right there. And right as I was up there, a salt truck came by. A plow came by with a salt truck, put down the salt on the road, and literally hit my feet as he went by. And I sat there and watched that salt, and it was a matter of, it seemed to me like it was 10 minutes or less before that road was clear. Now, obviously those were good conditions. The temperature was relatively high. There was sun on the road, but it was amazing how fast it cleared the road. And then it was also really embarrassing because by the time the tow truck guy got there, I looked like an idiot because that road was clear. There's a lot of different, so I had a list of the different types of salts out there before, and this is kind of a summary of the different salts that are out there, the relative cost of those, the amount of freezing point depression you get from those per unit weight you put in there, And then, Phil talked about this before, some of those things as far as, so you want to use the right deicers for the right conditions. And typically that means temperature. And so as we get colder, we tend to move away from sodium chloride and start using some of the alternatives like magnesium chloride and calcium chloride. I don't think anybody needs to know the specifics about that, but that information is out there. And I think we talked about earlier, even some of the alternatives have some bad side effects, whether it's beet juice or even the calcium magnesium acetate or CMA. They both, if they get in the waterways, they create a biological oxygen demand, and you can result in fish kills and things like that in the waterways. So, pretty much everything we put out there has some sort of negative impact on the environment. So salts, some of the issues we have with salts, these are two recent studies that came out, and they just reinforce the ideas that we already know. This one actually came out of Virginia Tech, so I knew well about this one, and was specifically looking at water that came off of roadways in Virginia as it went into the detention ponds, and then looking at the increase in the soils and waters, and they basically find what we know is that the salt increases in concentration with time. Salt is a conservative substance, it doesn't degrade. And so they see the levels basically rising and rising, and that reflects what Charles talked about earlier, where we're seeing the levels, they just keep rising over time. Obviously, we have impacts in the natural environment, the water quality, soil quality. Animals are actually drawn to the roadway. We do work with animal vehicle collisions. You'll see animals literally at the roadside or on the road licking up the salt because it tastes good to them and they need the nutrients. Actually, some of the plants along the roadside, you'll see this sometimes and not know what it is, and it's actually from salt impacts. The same kind of thing for crops. I put this on this slide because it's really a man-made environment what we're talking about here, but the impact on crops is actually fairly significant in many places. And then you see these kind of things on bridges, and there's a couple different things going on here. For one thing, rust that occurs on the steel. A lot of people think concrete's waterproof. It's not. Water and salt, for that matter, can move its way through concrete. Once it reaches the reinforcement rod that's inside the concrete, the rust forms on the rods, and it can create millions of pounds per square inch of compressive force. And concrete is not actually very strong in tension, and so it'll just fall apart, and it pushes that concrete off. So that's one type of spalling that occurs. Actually, there's a freeze-thaw spalling that also occurs where the water works its way down into the cracks on the pavements or wherever the structure. And when that freezes, it creates a lot of pressure and creates spalling. And there's a third method of spalling. That's where salt that gets into the surface of whatever you're talking about, concrete or other types of pavements, when it gets down and it crystallizes, when crystals form, it expands and it can actually create spalling. And so there's a lot of different mechanisms at work. This is something that we really haven't talked about too much, and I kind of alluded to it earlier, but a lot of the new vehicles that are out there now use a lot of different sensors for things: cameras, LiDAR, ultrasonic, different types of sensors, and they rely upon those for navigation in the environment. And as we see, this is actually salt on the outside of a vehicle, and so you can see where if we obscure those sensors with salt that's built up on the outside, that's going to adversely impact the performance of those vehicles. There's also a lot of direct impacts. We haven't really talked about that today, but when you look at kind of the life cycle of salt, there's a lot of indirect impacts. We have to go out there and mine this stuff, and that's a salt mine there. There's some that are underground. We have to transport it. We have to store it, and so there's a lot of different impacts. Now I'm going to kind of get into some of the technology solutions that I see there that are out there. One of the major things that we see as an opportunity for improving things with respect to winter maintenance is connectivity between vehicles and other vehicles, and between vehicles and roadside, or kind of like back to the back office. So the DOT has this program they call Connected Vehicle, and this is the idea where every car is kind of wirelessly connected to every other car with communications. It's a great program. They have all these different applications that they want to do with it. But it also turns out it helps with some of the other things we want to do. And so the reason I'm showing this is because we also have a variety of roadside sensors now that we can use. As you drive up and down the highways now, you can look for these sorts of things. When somebody mentioned iTerrace before, they use sensors like this that actually have a little lasers that look down at the roadway, and they can tell if there's water on the surface, how thick it is, and what state it's in. And they particularly put those on bridges, and so you can look for those on bridges in a lot of places. And then we're also actually doing some work with use of unmanned aerial vehicles for the inspection of roadways. In fact, that was one of the first projects that VDOT asked that we start thinking about was, can we start sending these things out to inspect the roadways after a snow? So for one thing, they can decide whether they're drivable or not, and then two, they can decide how to treat them. So if we have that sort of connectivity that we hope to have in the future, and right now we're looking at two different ways of doing that. One, something called dedicated short range communication. That's something that's been out there, but it's not out there in many places right now. VDOT does have a nice connected vehicle test bed up in the Fairfax area, where we have about 50 different communication nodes. The other way is, of course, cellular, and as 5G cellular gets rolled out, that's really going to have a big impact on this kind of connectivity. But one of the more recent studies we did was actually on Interstate 81. These trucks are outfitted, it's very hard to see, but there's a little sensor that's on top of the license plate here, and it's a laser that looks down at the roadway. And what it can do is it can actually monitor the pavement temperature. And then what they did is they used that. There were there's temperature thermometers on the truck. They can monitor the operation of the windshield wipers on the truck, solar radiation, and some of these other weather conditions that are needed to know so they can better predict the weather. And so as these trucks, these are actually on the safety service patrol vehicles that VDOT had on Interstate 81. So they're driving that highway pretty much constantly, helping people out and taking care of some of the hazards on the road. And so this is a really good way of monitoring the pavement conditions. So when you're looking at pavement, air temperature really doesn't matter so much when you care about what's on the roadway. You really need to know the pavement temperature. That has a big impact on what's going to accumulate. And so that's a critical piece of information that we're really not getting any other way right now. So we had this out on the highway, and this data was going back through the cellular connection to a central database, and then that data was being fused with a climatic forecast database. It was a company called True Weather was doing this work. And so based on that, they were able to make very granular, very accurate forecasts for the conditions of the roadways along Interstate 81. And that was very successful, and we're looking at moving it forward. Federal Highway Administration and others are actually looking at using vehicles, typical daily vehicles that we drive every day, as probes. Pretty much probably everybody in this room has a vehicle now where the wheel speeds are measured. And they have sensors on there that measure how fast the wheels turn. And the way the vehicle uses that information is it decides whether or not it needs to engage the anti-lock brake system or traction control or stability control or whatever to handle whatever situation's out there. But it turns out we can either use, if any of those systems are activated, we know there's a slippery spot on the road, so we can convey that data. We know where the vehicle is. We know that it just hit a slippery spot. And then we can transmit that information back to a central location where they can say, okay, hey, we just saw 10 vehicles that had a problem at this location on the roadway. And so we know there's a hot spot out there, actually a slippery spot out there. So let's send the trucks out there. You know, so when you start getting kind of more granular data about where treatment is actually needed, then you can start doing that. This is pretty much what I just talked about, so I'm not going to go. I'll skip through that. This is also interesting. This is a little project we had that we haven't done much with lately, but I was looking into how biochar was made using pyrolysis, and it's a pretty interesting process that when you make fuel from vegetation, from biomass, is that you have a couple things. You have a gas that's produced, you have an oil that you can put into trucks, it's basically a biodiesel, and then you have this residue that's left over that's kind of like charcoal. It's called biochar. And what's interesting about that is if the plants have a lot of salt in them, then the biochar is where all that salt will end up. And so what we were looking at is actually, if we encourage certain plants to grow along the roadside, these are called halophytic plants, then the salt that runs off the roadway actually concentrates in the tops of the plants. And then if we harvest those and we make fuel oil, and this is the biochemical conversion process where fuel oil is made, or biofuel, then we can put the biofuel back into the trucks to reuse it, And then the biochar, actually, what we were looking at is reapplying that back to the roadways again as it mechanically improves traction, but it also chemically reacts with the ice on the roadway and melts the salt. So, what we were doing, in effect, was creating a recycling of the salt that's applied to the roads. And so, also that kind of raises hope for some of the places like the parking lots that Phil was talking about earlier, in that they already have detention ponds in a lot of these parking lots where the water flows out. And if you were able to actually put the kind of plants in there that take up the salt like that, harvest them out, you can remove the salt from those detention ponds by harvesting the tops of the plants. Who's my timer out there, by the way? Okay. Have you already waved at me? Okay. Okay. I'll try to watch, but no promises. And we actually did some work. One of the main parts of work we did when working with the horticulture department at Virginia Tech was looking at some of the different plants out there and which ones were really good at taking up the salt in their tissues and growing at the right time of year. That's a problem too, because when the salts are coming off the road is not necessarily the best time for plants to grow. So we did some work with that, and I think that's all I had to talk about. And Phil, this was actually a picture as I walked out of the Kroger in Blacksburg, and there was salt all over the place, like some of your pictures. And I just found it ironic. I don't know if you can read that, but I think that's one of those things they put on the near the drains where it says this water drain. Yeah, so I found that so ironic.
Thank you. So we've got time for a couple of quick clarifying questions. Yes.
Are you still doing the biochar?
No.
Repeat the question.
He's asking if we're still working with the biochar, and the answer is no. We haven't been able to generate sufficient interest in that from anybody. You can imagine that's got to be tough though, going out there and harvesting along roadways. Doing, not that we don't already do that. North Carolina's been doing it with switchgrass for fuel oil production. China's actually doing it for tree growth. And there's other people that are already doing it just for the product itself. But in general, that's such a cross-cutting thing too with agriculture and chemistry and transportation. It's hard to get anybody interested in it, But I could really see it in an area where you have critical habitat or something like that, or a critical watershed. I think that's where it probably has most promise. Yes.
So you mentioned a pavement test bed in the Fairfax area.
Yeah.
Can you tell us where that is?
It's along I-66, and I think is it Prince William Parkway come through that area also? Is that it? I think it goes I-66 to the Belt. Is the Beltway connect with the Prince William Parkway? It's up in that area. It's right along I-66 as you come through Fairfax, and there's kind of a big triangle created right there.
So is it a VDOT facility, or are you associated with one of the counties?
It is basically a VDOT installation.
Okay.
They call it the Virginia Connected Corridor, VCC, if you want to look it up. Yes.
You mentioned the plants that can take up salt.
Yeah.
There's a lot of work going on to reduce erosion in our streams, with pour ponds and stuff like that. Do you know of any natives that can do the equivalent in stream beds if the flow is low enough to survive?
I think some of the plants that were actually most promising were natives, but it's interesting too. Is what we're seeing is, whether they're aquatic or not, I don't know. Like reeds or some of the or cattails or some of those, I don't know. It is interesting that if we looked at kind of the distribution of some of those plants across the United States, and because the salt levels are getting higher in the soil, those plants are spreading, and you see more and more of them now because they like the salt. And the other plants around can't handle it.
Okay. Great. So
Thank you.
We planned a 15-minute break. We're going to shorten it to, I'll say 5. Have you ever seen an actual 5-minute break? There's no such thing. People talk about it. So we're going to start promptly at 11:16 and make it a 10-minute break on this clock there. Okay? Can water